Hello guys, in today's Getting Started tutorial, we're going to talk about how to build an open data lakehouse architecture that is able to run even the most demanding data warehouse-like workloads directly on your open and standardized storage, with StarRocks as the query engine and Apache Hudi as the data lakehouse platform and table format. Hello everyone, I'm Cedar Shen. I'm the product marketing manager at Seller Data, and I'm also a StarRocks contributor. Let's get started. So first, Apache Hudi. Apache Hudi is a data lake platform that brings database and data warehouse-like capabilities to the data lake. Capabilities such as transactional properties, streaming, incremental compute, indices, and real-time observes, many more. Right? Two things Apache Hudi really does well is that first, it significantly improved the data freshness of legacy data lake systems, right? From high in the hours to low minutes, right? With mutable data too. And that's great for near real-time analytics. And second, Apache Hudi really provides a great foundation for modern query engines to run really fast queries, right? With performance that was only available with proprietary MPP data warehouses, right? Now we actually have a chance to unify all of the workloads, even the most demanding low latency, high concurrency, customer-facing like workloads directly on a data lake or data lakehouse architecture with open and standardized formats, right? Storage formats. And now let's talk about the query engine. The query engine StarRocks is a data lakehouse query engine that runs at incredible speed, right? It's able to directly query open data lakes, not limited to Apache Hudi, but others as well, such as Apache Iceberg, Delta Lake, and Python, right? And get data warehouse-like performance. So where is this performance coming from? So first, StarRocks execution layer is completely written in C++, so you can fully utilize the SIMD optimization, right? That's critical for running high performance multi-table OLAP queries, right? And is equipped with a hierarchical caching framework that's based on both memory and disk, and that's designed to accelerate data lake queries. It does two things. Well, first, it minimizes the I/O cost that's actually fetching the data from external storage, like a data lake, right? And second, it overcomes the low performance of the storage device that's typically data lakes are typically run on, right? Slow storage device such as object storage like AWS3, where the latency can be more than 100 milliseconds. And StarRocks is also equipped with the MPP architecture, which means that StarRocks is able to perform data shuffling, actually the entire query process completely in memory, which is really optimized for low latency, high concurrency query workloads, right? So with StarRocks, especially when paired with a modern data lake house platform such as Apache Hudi, there's no need to copy even the most demanding workloads to another query acceleration layer, such as a data warehouse for query acceleration reasons only, right? And that does two things. So first, it simplifies your data architecture. And second, you're able to keep your single source of truth data on your data lake or data lake house, right? And that's great for data governance. And now let's take a look at some performance numbers. StarRocks compared to Trino. StarRocks is 5.5 times faster than Trino on the TBCDS 1 terabyte benchmark test. And TBCDS has a pretty complex query set with a lot of joins and high cardinality aggregations. And this showcases how fast StarRocks is when compared to other query engines. And now let's take a high-level look of our demo, the architecture of our demo. We're going to have StarRocks as a compute layer and Apache Hudi as a table format that provides the metadata format, right? And MinIO as a storage we're going to use to persist data that is going to generate it and ingest it by Apache Spark into Apache Hudi table, right? And we're going to use Docker Compose to bring up all of the services we need, all of the containers. And you're going to be able to run everything on your local machine, right? And now let's get started. There are two prerequisites to run this demo. First, you want to have a Docker environment. See, this is mine, and there is no Docker container up at the moment. We're gonna do them very soon. And second, you are going to want to grab this GitHub repo that has all of the necessary config files that we're gonna need to complete today's demo. I already have this downloaded right here. And you want to go to this directory within this this GitHub repo after you clone it. And we're gonna do everything from this directory, right? And here is the Docker compose YAML file, and we're gonna use it to get the containers up for now. Right now, because it's gonna take around 30 to 60 seconds to get ready. In the meantime, let's go over all of the containers that we just spawned. So first, StarRocks FE and StarRocks BE. Those are the StarRocks processes. StarRocks FE is in charge of query planning, metadata management, and this is actually where the cost-based optimizer is in. And StarRocks BE are actually like the muscle of the StarRocks cluster is in charge of actually scanning the data and executing the queries, right? And this Metastore DB provides a Postgres DB that's gonna store the Hive metadata, right? And Hive Metastore is just a Metastore service, and Spark Hudi is going to provide the Spark environment that we're going to use to generate the data and then ingest into MinIO in a table that's managed by Apache Hudi, right? And MinIO is the locally deployed object storage we're going to use for today. And this is locally, and if it's on the cloud, that would be, for example, for AWS, that would be AWS S3, right? And that's completed, and let's take a look. And here we have the config folder that has a lot of configurations for Apache Hudi. And this config file is going to be automatically mounted into the Spark Hudi container, so we don't have to worry about it, right? If you want to learn more, you can go into and see actually each config file. So first, we're going to create a bucket inside of MinIO for the data to be stored in. And let's do that right now. Now we're in the MinIO console, and we're going to use this console to create the bucket, which we will ingest data into, right? To log in, you can find the username and password in the Docker Compose file. But if you haven't changed the Docker Compose file, this will be password as password and admin as the username, right? And you can log in right here. To create a bucket, you go to bucket and create bucket, right? Let's call that Hudi test. We create this bucket, right? We're gonna populate this data with Apache Spark, and it's gonna be a table that's managed by Apache Hudi, and we're gonna use StarRocks to query that table directly, right? To populate the data, let's go back to my command line interface and do that right there. So now we're back at my command line interface. So first, we're going to enter the this Spark Hudi container and initiate Spark shell, right? And this is we're going to use to generate the data and ingest into MinIO, right? I'm going to give it a second to get started. Okay, we're in Scala. So first, let's import some libraries. We don't need to worry about that. And then let's generate some data, right? So what this does is that we generated a data frame that has 3 columns and 3 rows of data in string format, right? And then we create some variables, right? Database name, table name, and the base path. See, here is the bucket we just created in MinIO, right? It's pointed to this S3 bucket in MinIO. Let's do that, and then actually write the data into the Hudi table. It's gonna take a second. Now this is completed. We can exit. Now we're done with the data ingestion, right? And now we want to connect to StarRocks and actually connect StarRocks with Apache Hudi and to query the data that's stored in MinIO directly, right? And to access StarRocks, we use the MySQL client. Here, I'm going to use the MySQL client provided by the StarRocks FE container. But if you have your own MySQL client, you feel free to do that as well, right? So first, let's create the external catalog. So that's a connector that StarRocks use to access external data, right? And we can set the catalog to this catalog name that we just created, and we can show the databases that are in it, right? And this Hudi sample was the one we just created with Apache Spark, right? And if we want to use this table, and now use this database, and now we can show the tables, right? And this is the table we just created, and now we can query the 3 rows of files that we just generated with Apache Spark. And now let's go back to the MinIO console and see what we just created, right? And we can see that this Hudi test bucket is populated with some data, 33 objects, and we go into it. Hudi coder is the table, right? And this table is partitioned by the language column, right? It's specified in the in Apache Spark. We'll just take a look at one. You can see here is the Hudi metadata, and this is the Parquet file, right? Actually storing the data. And this is all I have for this demo. And this demo is actually available on the StarRocks documentation, right? If you want to try that on your own, you go to the documentation, go to QuickStart, and see Apache Hudi Lakehouse QuickStart right here, and follow along. Thank you everybody for watching. See you guys again next time.